Up to the last session of the day, and I'm very excited to be the moderator for this panel, which is on AI and open standards. And I have with me a really, truly fantastic panel of 4 distinguished panelists. Unfortunately, Siddhi Shah, who is Senior Patent Counsel at Micron Technology, could not be with us in person today because she wasn't feeling well, but very luckily, she accepted to anyway join us virtually, and she's gonna be with us for the panel, even though we weren't able to get her video up. At least she will be with us, and she can speak, and we can hear her, and she can hear us. So, in addition to Siddhi Shah, we have the 3 people you see to my right. So you have Bowman Heiden, who is one of the leading academics in the field of SEPs with Berkeley's Haas School of Business, among other affiliations that he has. And then we have Prakash Sangam, who is a founder and principal at Tantra Analyst. So a distinguished technology analyst, a frequent writer about technologies with lots of industry experience about especially wireless, but also other technologies. And then we have An Fan, who is the vice president and head of IP at Huawei Technologies. So as you can tell, a lot of diverse backgrounds with different types of experience with standards and AI. So I just wanted to kick off the panel with just a few thoughts to tell you what kind of led us to have this panel on AI and open standards. Obviously, every conference needs a panel on AI, so this is the quick answer to that. But there's a little bit more thought that went into this. And the way we saw this is that there is at least 3 different conversations about AI standardization going on. And we felt that for a conference like ours that generally tries to pull up the conversation on a little bit of a higher level of overview, it would be a good, ambitious task to try to bridge these different conversations. So one conversation is about AI standardization in the context of legislative efforts. So in the EU, there's the AI Act. In the US, there has been the executive order on AI. So these are legislative initiatives that very heavily emphasize the need of standardization of AI for the purpose of ensuring safe and responsible AI. Then there is a conversation that includes AI among these critical and emerging technologies where there's a lot of concern for countries' respective positions in the development of international standards for these critical and emerging technologies. So, for example, the US government has published a US government strategy for standardization in these fields, and it has obviously included artificial intelligence among the critical and emerging technologies where the US government has expressed its concern or the value that it attaches to US leadership in these fields, and obviously other countries' governments similarly take a very strategic approach to their country's position in the development of these standards. And third, there is long-standing industry debate about open standards in fields such as wireless communication, multimedia, where issues such as intellectual property rights are debated. And these technology standards are also increasingly being shaped by AI. And AI might shape some of these conversations that we've had in this kind of context for a very long time. So there are at least 3 different conversations. And very often these 3 conversations are being led by different groups of people. So it's kind of important to see common threads between these. So this is what we wanted to try to bring to this conference, and where it's interesting to have this perspective from IP people, people from the big companies, people from different countries, academics, technologists who have written about these different technologies. So we try to kind of identify the common thread these different conversations to identify maybe possible, possible solutions and possible avenues forward. But to kick it off, we decided that it would be interesting to first lay out a little bit the landscape. What is going on in terms of AI standardization? Where are we? What are the different things that are being done right now in standardization of AI? And so I decided to ask Prakash to kick us off, because you are frequently writing about the latest developments in technology. So maybe you could just give us a little bit of an overview of where you see AI standardization standing right now. And then we're going to hear from the other panelists about their views on that before moving to the next topic.
So yeah, thanks for the opportunity to be here. So AI and standard is an interesting concept. Right now, the most of the standardization effort, as you pointed out, is in terms of making AI responsible AI, right? It's coming from regulatory bodies, from the governments, and so on. As you pointed out, AI Act, I mean, European Union is always a leader in how to control things. So they are the most prepared and most structured one to put standards requirements from a regulatory point of view to make AI fair, privacy protected, unbiased, and in terms of data governance and so on. So I think that's a good initiative. US is more of hands-off approach. All that NIST and other things, other entities have done is basically provide guidelines to make in terms of how to make AI responsible, right? I mean, how you want to define responsibleness, mostly from privacy, fairness, and then data governance. So those are the three main things they're looking at. And of course, China, I mean, in its own world, we exactly don't know how things are shaping up there. Of course, these responsible AI things, these standards, need for that is basic, in my view, but the needs are much beyond than those basic things. I mean, in terms of interoperability, right now, if you look at AIs, each of them are in their silos. If you look at Google, Microsoft, OpenAI, and other open source things, a lot of them are in their own silos. There is hardly any interoperability between them. Typically, if you look from a standards point of view, the basic need of standards, rather than responsible, is interoperability, right? If you take my background, which is wireless, in terms of for wireless, the standards are basic need, because you have two entities, they have to talk to each other. You have to have a common language for them to talk to each other. So it was a basic need. In terms of AI, the responsible AI is the basic need, but interoperability is not so much, right? It is kind of more forced upon them. Is anything happening on that front? Yeah, although it is not the main thing on the back of the mind of the developers or the big companies who are working on AI. But there are some efforts. Oasis is one, and there is initiative with many big companies coming on to making AI responsible, not so much on interoperability. And in terms of standards, there are and interoperability itself, there are many aspects to it as well. I mean, model compatibility is one. Whatever things you have done on one model, easily transferred to other models. That is one. But also interoperability between different hardwares. So for example, if I'm developing stuff on, say, NVIDIA using CUDA framework and so on, can I easily transfer that to some other platforms? And none of that is happening right now. And if I develop stuff on, say, on GPU, but if I want to move that to a heterogeneous compute in terms of TPU, CPU, and other things, not so much is happening there either. All of these are at early stages, and then as we move towards hybrid AI, wherein there is cloud AI, but more and more AI is moving towards the edge. So how you divide the workload between these two? Who decides what workload goes on where and what point of time for what kinds of workloads? That also needs a lot of interoperability and some sort of standards. Nothing of that sort is happening right now. A good example is, you might have heard Apple announcing their intelligence a couple of days ago. They basically clearly mentioned, depending on the workload, things would run either on the device, on the phone or the laptop itself, or on the cloud, their own cloud. How do you, move between who decides and all that kind of stuff? It's easier to do when it is a vertically integrated company, all components coming from the same company. But if, for example, take Android or Windows kind of scenario where SoC is coming from somebody else, the operating system is coming from somebody else, the apps are coming from somebody else, it is very hard issue to solve unless you have standards as such, or to have a good standard framework to do these things, right? So just to conclude, as we all know, standards are needed, but right now the industry focus is more on making standards for responsible AI, not so much for interoperability between different silos, if you will.
Thank you, Prakash. So maybe I can next turn to Siddhi. So as Prakash has said, many standardization efforts in the area of AI are in response to regulatory needs. But standardization is also a means of fostering open innovation in a technology so that different companies can specialize and focus on the different areas where they are best at. And Siddhi, maybe can you give us a little bit of a perspective where we see standardization in AI in more closely related to the technology itself and where the frontier of AI standardization sits on the technological end right now, from your perspective?
Yeah, absolutely. I think, as Prakash mentioned, industry-driven standardization initiatives haven't been that much forward within AI. It's just the regulatory standards at the moment. But as we all know, that a lot of AI infrastructure platform development is already based on open source software, and also we have realized that as AI is getting widely accepted. Organizations are realizing the need for, logically organizing the data, defining ownership, and then just having a simplicity, consistency, and interoperability for, data governance, discoverability, observability, a lot of other things. And this evolving landscape of AI, there is a lot of need for having this type of open standard that can allow unify the framework across different tools so that all different AI systems can work together seamlessly, regardless of who developed the platform, who developed the models, and where they're running, especially when a lot of companies have shown interest in edge computing for AI. That means your phone will be itself, performing certain AI, and in those cases, obviously, there is you need a lot of interoperability between all different tools. In addition, just making and running AI ecosystem is challenging and hard. That involves billions of parameters and lots of computing power, and that even just emphasizes the need for having more of interoperability so that it can be accessed by wider range of users. So, and then, yeah, of course, with respect to transparency and innovation, also, having common framework for the data model management and different tools is definitely helpful. Also, like with respect to transparency, making AI system how the data is processed and more transparent really helps user understand how they work and how the decisions are made. Especially, we've all seen hallucinations around ChatGPT and other systems. So, and they are very much closed systems that we don't know what's happening in there. And so, having standards that are, that allow this type of interoperability, innovation, transparency, and also, having that trust, because AI revolves so much around a lot of data, and we want to, ensure that the ethical and principles are also, well addressed. Obviously, the regulatory standards try to address them, but with respect to privacy, security, having open standard can really help foster, build trust within AI system as well as the users. Just to add into that, overall, obviously AI infrastructure, I think there could be, it wouldn't exactly like how the 3GPP or the wireless or the cellular or the IoT device type standards are, because it's combination for many things. It involves infrastructure that it's open source. It could involve a lot of data and learning from data, and that could be, there wouldn't be any pattern around them at all. And then there would be some SEP as well, where the AI learning predictions and other aspects of AI are used within 5G or other areas of wireless or other technologies. So when it comes to AI, licensing and infrastructure building and with respect to standards, it could be a mix of all of those things together.
Excellent, thank you very much. And once again, also thank you for being available to speak with us, even though you weren't able to be with us today. Alan, your company is obviously leading participant in many different standardization efforts in many different technologies, including technologies that we often think of in this kind of community here, like such as wireless and multimedia. So what's your experience with the increasing use of AI in standardization in this context?
Sure. I think I want to begin by saying there are two types of very different standards. And there's a kind of standards used for regulation purposes, for safety, for security. There are standards for construction, standards for automotives, making sure that when you are hit by a car, you're hit by the leg. You are not hit on your spine. So there are, drinks, water, air, all sorts of those sort of standards. Those are for regulation purposes. And there's also another kind for technologies. Typically, when you have new generations of technologies, these new technologies, create new market demands. And these technologies were developed jointly by competitors. So there's an antitrust concern. There's no antitrust concern of the first kind of standards, by the way. But there are all different considerations belonging to these two very different types of standards, which is unfortunately happen to be using the same word, standard, in this context. So it caused some confusions, actually. And both in Chinese and English. So I guess, certainly we need a more, this first type of standards when it comes to AI, because new technologies are difficult to be regulated. Information technologies in particular, when we'll think of, internet, cloud computing, it's all very, very difficult. It's becoming increasingly difficult to regulate. So I guess scholars got to be spending time on that, to figure out what is the best way to recommend to the government how to regulate this new area. And when it comes to the second kind of standard, the technology standard, technology companies have already started using AI in standards, telecom standards, for example, and standards using AI to, for example, compress information. And at different layers, it can be compression at a application layer, like compressing the video, the images, compressing also at a lower level. For example, what we call physical layer. The baseband processing. Technologies has already been developed so that it can be potentially used at different layers of communication. Just think of it. The artificial intelligence is very is ideal, for these purposes. When you, I guess, for example, for generative AI, you basically put in a prompt, and there's a machine already trained with some pre-trained data set that can infer, or somehow figure out what you wanted to have. Right. So when it comes to communication, what you are really doing is to when you have the inference systems on the other side, what you can do is just to put in the prompt. You don't have to transmit the actual information. You just put in the prompt, and if there's another model on the other hand, on the other side of the communication channel, that it can infer the things out. Whatever it is, video or picture or text. What you can expect from the other side, is original information. So you compress on one side, and infer it out on the other side. So that's basically what a communication is. So artificial intelligence, it is very, very useful in our area, so to say. But I mean, there's no, I don't think there's going to be a AI standard, technology standard, because just as Prakash said, it's going to be in silos. AI can be used in, one technology is to solve one problem. Other technologies in AI, I guess, to me, is more or less a mess, a kind of mess. There's no standard for math, right? You use math in all different kinds of technologies to solve different problems or in different silos. So that's basically where we are, the status of art. But basically, it's a new technology, so a lot of more applications will come along.
Okay, so we've heard about standardization efforts in AI technology. We have heard about AI popping up in other technologies that are being standardized. We have heard about standardization that is coming from the regulatory side, that is more from the technology side. There's standardization of the hardware, standardization of more the software side or the interfaces. And so it seems that there are different standardization communities, and which probably have their different ways of operating. And Bo, you have written and thought a lot about emergence of norms and standardization and convergence between norms. And so I was curious whether you have observed this field a bit and have some thoughts about whether there is kind of a new set of norms, a new community shaping up where like it's these different types of standardization efforts might ultimately converge.
Yeah, that's a good question. I think we all understand now that when we talk about standards in the term in AI, we're talking about something different than when we talk about with wireless. In fact, a lot of standards have come out from a market effort of de facto competition. If you go back to the automotive industry, in the beginning there was hundreds of different types of styles of cars and different designs. They competed against each other until there became a kind of dominant design, is the term we use in strategic management. But that's about producing a standard of sorts. That doesn't mean that one company was in the end, but all companies started to produce cars with 4 wheels and windshield wipers and internal combustion engine, which wasn't the obvious thing from the very beginning. And so I think that's what we see here. We don't have this gathering of people into a consortium-based consensus standard at this stage, at least. And maybe you could argue that it was like that in 1G and 2G and in cellular as well. But people are starting to put forward different designs, and it's creating a set of norms about where are we going to operate. and we'll talk about this a bit later, but what are we providing? Are we providing source code for people when we do this? When we produce our models, are we producing how we're doing the training data? Where are we on how open we are? So these norms about what does it mean to produce an AI system, and does it and what types of how the market responds to what they want is going in parallel with how the government is deciding how to handle this responsibility, as you say. So while everyone's producing their own designs, certainly some of them are going to be consolidated. People will say, well, we only want these types of designs going forward. These are the ones that win in a Darwinistic competition. The European Commission has kind of said, and you need to do this, otherwise you're going to be regulated, which is another way of creating some type of de jure standardization pressure. So you have a de facto battle with this de jure top-down combination, which is going to lead us to a set of market and policy norms, I think. But we're still in the beginning, right? We can all shape the norms. We're all part of the battle or part of the design.
Excellent. So we already touched upon it, but I wanted to develop it a little bit further. So in addition to standardization in different fields, there are different types of standards. So we heard about open standards, and this is kind of the primary type of standards we're primarily interested in, but we've also heard about open source being an alternative model of coordinating efforts in an open innovation effort. And then, of course, there are many proprietary standards in this field. So, Siddhi, maybe I was hoping you could walk us a little bit through the basic differences between these different models in the context of AI, what makes the model as more or less suitable to AI standardization, and whether you think open standards will emerge as dominating model for standardization in some aspects of AI.
Yeah, absolutely. So I think AI, machine learning AI we know for a while. I just wanted to clarify that it's generative AI that's new, but machine learning has been in place for many decades. And yes, all types of different standards, whether it's proprietary, open source, or open friend-based standard, or just separate type of licensing for data that is being sold or just used by everyone who's using the product. There could be many different ways of monetization techniques, or as well as standards for AI, and that combines the entire AI ecosystem. And with respect to semiconductor, for example, there's definitely some proprietary standard, like Prakash mentioned earlier. NVIDIA, they have NVLink, and they have a very high bandwidth GPUs, operability because of that, and it's market leader at this point. And because it's a closed standard, not everybody's making semiconductor that can compete or use a similar. So there is definitely proprietary standard like that. And then with respect to end user applications, when AI involved in that, we would want to have more of an open standard for models, for data to understood between different systems and end user application or end device. And in those cases, obviously, open standards would be very helpful, as we discussed earlier. And a lot of open source comes around large language model development. So many different companies have come up with their own large language models, and there's a lot of platform infrastructure being developed around that. So those large language models can be used in different ways, and the open source community for AI is huge. And I think both open source and open standards would fall in the same category of open standard would also allow them to use any patents or IP associated with those technology freely. Similarly, in open source, there are licenses, Apache, other licenses, they would allow also the use of the AI technology on a freely basis. And I think the last one would be the friend-based standards, which obviously if AI is involved in any technology that is already being part of technology that are like wireless, multimedia, 5G, 6G, there has been talk about AI, generative AI in RAN and wireless multimedia, managing traffic loads, edge processing, even in computing or base station or different accelerators within the wireless technologies. And then those cases when AI is integrated within those products, that would be, there would be patents associated with it, and those would be, under the friend model or SEP models. And generally, a lot of AI patent applications haven't been, considered or valued very highly, just because, there's a involvement of neural network and a lot of different AI technology that is very rapidly changes. Every 2 weeks, we have a new neural network. So, however, when they are broad application-based patent applications that are pretty useful, and especially when they're included in the wireless and multimedia and other technologies, they would, have as high as value as other type of wireless technologies.
Thank you. I wanted to turn next to Prakash again. So with respect to that question of the role of open standards for AI, so we already touched upon some of the differences between wireless and AI in the sense that interoperability is critical for wireless in a way that it might not be for AI. But I mean, can you a little bit develop and maybe tell us what, from your perspective, differences between these standardization environments are, and what maybe some commonalities are, and where, like, it's some of these standardization models that we are experienced with from the wireless context do make sense for AI from a tech maker's perspective?
Yeah, sure. So to look at open standards and open source, I think cloud ecosystem is a good starting point, because if you look at the AI ecosystem and cloud ecosystem, there is a lot of commonality, right, in terms of players. So if you take cloud, an example, it is built on open architectures, and a lot of it is open sourcing, right? So, but still, in my view, is built in silos. So, for example, I mean, you look at hyperscalers, all are working on the same open source and open architecture model. But if you go and ask IT managers, if they are a Microsoft house right now, and they want to move to, for example, to a Google hyperscaler house, it's possible, but it's very difficult, and it's a lot of friction if you want to move from one to other, right? Although these are both are built on same open architecture, same open ecosystem, a lot of it is open source, but they're still silos. I think, as an analyst, that'll have, at least for the near future, AI ecosystem will be, right? So you have, there are lots of open source models, right? And there are proprietary models as well. So which means, with the open source models, the source code is given to them for use within guidelines. So a lot of developers would develop applications and other things for that silo. So it'll be a good enough, wide, vibrant ecosystem, but within that silo, not so much interoperability, right? So that's looking at cloud and how cloud has developed, and how it can foretell us AI will move forward. The other aspect to contrast is on the wireless side. There's a lot of AI happening in the wireless before all of the ChatGPT kind of thing started, if you ask me. And then it was called AI and ML, not so much Gen AI. So and wireless 3GPP, which is standardizing it, gives good, I think, a roadmap for other industries to standardize as well, wherein they're looking at, okay, so as you might know, closing a wireless link is a very difficult task and a very formidable challenge. Obviously, AI is one of the excellent solution to solve that challenge, and that's what wireless industry and 3GPP is trying to do. Now, but they have this conundrum, right? There are two sides to this wireless link. You have a network side and the device side, and obviously there are different players on both sides, and they want to develop their own model on both sides. Then the question becomes how you make sure these are compatible to each other, work with each other without, against cross purposes, and to improve the performance overall. But at the same time, none of these guys want to give away their models or expose their models to each other, right? So they're developing a framework on, you exchange inputs, you exchange model parameters on how these decisions are being made, while keeping their secret sauce of the models to themselves, and then make sure they work together. We'll see. I mean, there is good work happening, but still, many of these are in, as they call it, study items in release 18, which is almost done, and are moving to work items. So they basically studied how to do these things, and they have some idea, and then they're moving on to a stage where they'll actually work on the protocols and standards in next phase. So, I mean, that's at a high level how we can contrast and compare.
Okay, yeah, thank you. And so this is like the contrast on the technology level, but I'm also interested in the company perspective. So like we are familiar with the usual incentive problem for companies, whether to participate in a wireless standardization effort, where like it's for the companies, the choice to heavily participate as a contributor is mostly about the monetization of the contribution that you can make to that effort. And in the AI space, that might be different because the upfront investment might be different from the upfront investment that you have in a wireless environment. Some of these things may, but other may not be patentable, and also like just the general relationship between investment and standardization might just not be the same. So I'm interested to hear from somebody at a company like Huawei, and also somebody with an IP role at Huawei. Like, it's what is your strategic calculus, whether to participate, how much to invest in an AI standardization effort, and is that very different from wireless or multimedia standardization effort in a traditional way?
Well, I guess there can be differences, but I guess we're now talking about the technology standards, not the safety, security, for the regulation purposes. I think there can be some confusion when we talk about open standards, open source, proprietary standards. So I think I want to first clarify. Sometimes when we talk about the open source of AI, what is actually open sourced may not be the algorithm itself. Could be the parameters, the result of the training. So the original data set, the training algorithms, the method for training, typically, oftentimes are not open sourced. Sometimes there are, but not necessarily. When we talk about open source of AI, it means the original open source code kind of open source we were thinking about. For example, I think Meta had this Llama 2, they call it open source, but what is open sourced is actually just large data files, basically parameters. So I think to eliminate this confusion, I guess maybe I can suggest, at least for the purposes of my elaboration, I can call the standards, categorize the standards into two types. Symmetric and asymmetric. Symmetric standard could be is typically the communication standards, because all communication companies are relatively equal, on equal footing when they, for example, come to 3GPP, because they need some kind of products to be connected to the network, either on the infrastructure side or on the device side. So they are all building or interested in connecting some kind of products into the network. So they have relatively equal status, not exactly equal status, because Huawei, Nokia, Ericsson kind of company and Qualcomm kind of company may be a little different than others that is just only building phones, but relatively equal. Well, on the other hand of the spectrum, there are this asymmetric standard. For example, the standards led by Intel. If you look at the schematic of a computer, you see a big block in the center of any schematic, which is the processor, the central unit processor, and everything else, the small blocks, are called peripherals. So those are the other players of the industry. They are called peripherals, and there's a central unit processor. So they're different. They are asymmetric. This different status may lead to different business models. For the first kind, when it is a symmetric standard, typically is operate based on friends. When it comes to IP. Well, on the other hand, when it comes to asymmetric, typically is free standard because it's mostly developed by this guy building this center block, and so it's open, but it's mostly developed by one person. So others, when they want to contribute, their contribution may or may not be adapted, because they may or may not be, fit into the strategy, business strategy or technology strategy of this person offering the central processor or central unit, and can be in forms of a standard or technical paper, technical specification. It can be also, provided in the form of open source, free to use, but it's actually used to connect to a larger, sometimes monopoly ecosystem. So I think there are two very different kinds of standards. When it comes to AI, well, I guess as I said, AI is just a math. So in different use cases, if it is a symmetric ecosystem, or if it is a symmetric ecosystem, the use of AI or the standardization of AI and the underlying, for example, the IP policies can be very different. Just like what happens to technologies, there can be different challenges. For example, AI. When it comes to AI, what is the you cannot use traditional patent claims, the method claims, practice claims to protect a large data set, right? So sometimes you face new challenges. But at the end of the day, when it comes to what needs to be protected, what intellectual property can offer to support these ecosystems, they can be probably categorized as symmetric and asymmetric.
So we should probably rename. Yeah, sorry, Siddhi, go ahead.
Oh, I was just going to say I can add a little bit into that. As we all know that in the traditional standardization process, the large companies with a lot of resources would work with the standard body, and there is obviously incentive for them to share their technology and make it available and for others to use. It's definitely different when it comes to AI because, to make AI more transparent and interoperable for, data handling, model interactions and other across different platforms, we want to have a standard that enable, these aspects of usage. And also, while at the same time promoting competition in the market and prevent single user from monopolizing anything. However, with open standard, there are no incentives, and then that may impact the quality of standard or, because there's no incentive for that person or company to work with a standard body or offer their technology under friend. And sometimes some of it has already happened, like with OSS and other, that it's steered, all of these standards for AI are steered by very big companies, and because they are directly making products according to them, and the best technology standard may not be adopted because of that.
Yeah, just to add, I mean, right now, there is no big incentive for these large companies to make their models, at least at this point of time, to be interoperable and work with everybody else. That's more from a priority perspective as well as business perspective. Priority, they're still in the phase where they're trying to make these work in a consistently good way, right? And so standardization, interoperability, I think, is secondary in terms of priority for them. And even if they want to make it interoperable, is there a big business incentive for to do that to them right now? I don't think so. I mean, they've spent so much of money, and then things. If they make it fully interoperable, then how is the return on that investment going to come from, right? So I don't see huge incentive for the big companies to make it really fully interoperable right now, basically.
Okay, so even though we're changing the terminology a bit and might have to rename the panel to AI and symmetric or asymmetric standards, so this notion of open standards is particularly interesting actually in the case of AI, because we have all these different meanings of the word open in this context. Openness of the algorithms, openness of the training data sets, which are very important in AI, openness of the parameters, openness of the way how AI models are benchmarked and compared with each other. So we have like this notion of openness is problematic, or it's at least it's richer than we are used to it. And the other aspect that is interesting is that we have open and open source, we have open and open standards, we have open and open AI, and each of these different contexts imputes a different meaning on the word open as well. So Bo, I know that you prepared some points on kind of this notion of openness and the strategic choices of opening up and in the context of AI technology development. So I want to.
Yeah, good. I'm going to give a lecture now. So, yeah, there's a joke about speaking in public. It goes like this. It says, you wouldn't be so afraid of speaking in public if you knew how little people were paying attention. But look, she took that personally, didn't she? Let me just go through a little bit of a framework that we use on this idea of open innovation, what we mean by openness. So typically when you talk about these open platforms like 3GPP, or if you talk about Bluetooth or MySQL, I'll get to some of these in a second, we can break this and make it very simple and talk about the platform is open in 2 dimensions. It's open from a development perspective. David, you're going to do quality control on this, right? Okay, that's good. So the development side, so who's participating, how are changes made, so who gets to participate? So in 3GPP, there's a whole process about who can participate, there's a consensus mechanism, and so forth. And then there's the distribution. How open is it? So who can have access and on what are the terms? And in 3GPP, you have to pay a FRAND royalty rate. In other types of platforms, it's royalty free. It just depends on the nature of this. And one of the arguments that we make is that this is designed strategically. So the openness that people use, the way that they design it, is done strategically. So when Apple decides to have their iOS closed, they want to create this walled garden. It's part of their strategy, right? When Bluetooth was created, companies like Ericsson were willing to put in all the development themselves and make it open because they weren't trying to make money off of Bluetooth. They were trying to sell more mobile phones. And this was good for doing that. So there was a reason for the openness because it facilitated value creation further down the chain. Now they don't make mobile phones anymore, so it's maybe there might be a regret, right? And you could, of course, put Android there as well. So Android does a lot of their own development. That doesn't mean you can't fork it, but they do their own, and then they give it out for free, not because they're being friendly, but because it's part of growing the business of which they can link to the double or triple-sided market towards apps and advertisers. Same thing, so LT, we talked about MySQL, they were their own company, so that was open source 2.0, And their development was not to allow other people to make the code, but to allow them to debug it very quickly. And then they offered a non-commercial license, or a free license for non-commercial use and a license for commercial use. And then, of course, Linux, that most of you know about. It, of course, its purpose when in the beginning was very altruistic maybe, but very quickly companies started to realize this is very useful because Microsoft controls the operating system space. So let's put a lot of money into this. It was very open for people to contribute, but if you want to create, but what goes into the next kernel is still controlled by a group of people. And of course the GPL license is a copyleft license. It's a very strong IP license, right? It forces you to share alike. So you can't just do whatever you want. It's not permissive license. So there is a kind of control. Now, it doesn't cost anything, but if you contribute to it, you have to share alike. And you can't make money off of Linux specifically. You can make money off of services around Linux. But you can make a lot because Red Hat was sold for, what, $34 billion. So this is the type of, so you can analyze it from these perspectives, but you can also design where should we put the openness depending on our business model. So now if we move into LLMs, then this is I've started to work on this. I would probably organize it differently, but for now I just wanted to use a previous study because they had gone through this in a relatively good way, is that they talk about availability, documentation, and access. One thing that they don't necessarily talk about is this idea of development, like who can participate. And I think that has a lot to do with the fact that no one is really participating in groups. They're all doing their own thing now, right? But then they leave it open, so it's more down here closed, and some are more open than others on this. So if we look at this, you'll see, and of course, one of their model, what they're talking about, you should know that when they do this, they're coming from this idea of open washing. So they're critical that people are claiming to be open when they're really not. So as you were saying, Llama 2, according to them, is not very open at all compared to Bloom. So there's no open code, there's no open data, there's some open weights. That's what you're saying, the weights are available, right? But not the training data, not the some of the training weights, so they open on weights. They don't offer an open source license. You can't see the code, and so forth and so on. And of course, the documentation becomes important when it comes to the regulatory perspective, because if you don't document things, then you get in trouble with the European Commission or the European Union. And then you can see that, you know, ChatGPT is produced by a company that's called what? OpenAI. It doesn't look that open at all, does it? So you can see that we have an issue here with the idea of open, and open has always been ambiguous. So it requires a context, and in this context, we're starting to understand what open means. And this is again going to be the battle. So if you're, you know, if you want to listen to Mark Zuckerberg, he's pretty open about Llama, why it's open in the way that it is, and he uses the word open source all the time when he talks about it, which these people might not agree with. But it's a bit about, we want to make sure that we don't get blocked by other people. We don't want to have to use Google's LLM. If we put this out there, other people will do things, and we don't want to make money off this itself, but then we will use the benefits of this towards the other apps that we do. So again, if you do complementary things, then you're more willing to open up, although, again, not as open as they say. Again, this is an opinion. So again, this types of thinking, this is what we're going to be going through when we talk about openness. And the regulators are going to get into this, but also if we start to form more consortiums or come up with different norms, we will have to figure out what we mean and come to an agreement on what open means and what it doesn't mean. Thanks. Oh, one last thing. You can find this report, by the way, and they went through 40 different LLMs and basically came to the conclusion, not so open as people say, right? So you can look at this report. All right. I'll go back, oops. So our friendly faces. There we go. Thanks.
Thank you very much. It's always good to...
I get to count this for my academic work for the year, right, David? Thanks.
Always good to have a lecture in the middle of a panel that's going to wake people up.
Couldn't get away. You wanted to get away, but you couldn't.
So...
just to add, OpenAI is as closed as it can get. There's absolutely no patents, no open source, no accessibility to anything for OpenAI. So it's very closed. trade secret sauce that they have got.
There's multiple IPRs controlling this different openness. Yeah.
So before I open the floor to the audience, I wanted to have one round of relatively quick reactions, or maybe like it's some thoughts on a topic that is of interest to this crowd, I believe, is standard essential patents and IPR policies of standards organizations which care deeply about standard essential patents, so organizations such as 3GPP. So I wanted to hear from you, what are your thoughts on, will AI be important for SEP debates going forward? Will SEPs be important for standardization of AI when we see more of it, of the interoperability standardization? And are the IPR policies that are currently in place in organizations such as 3GPP fit for purpose? Or are there areas where we need to think about changing some of these aspects in order to accommodate the specificities of AI and heavily AI-dependent technology standards? So maybe, Alan, why don't you kick this off then?
Yeah, I can try. I think I want to first echo, what was discussed previously about the lack of openness, even when we call it as open. I think, the ICPs are used to incentivize opening of technologies because, when you open your technologies to the standard, if you have ICP, you can still be warranted of some sort of, royalties. So it's used to incentivize openness. So it's useful. It has been working for 3GPP and for many other standards, mostly, again, the symmetric standards. I think that, whether it is open, it is symmetric, it is consensus-based, it is decided by the ecosystem, the application. Because if it comes to a ecosystem that everybody is equal-footed, then probably you need to find a way to use intellectual property so to protect the contributions, also to incentivize contribution. Well, maybe if it's asymmetric, maybe there are other ways. The contributors, the one opening up their technologies, can be rewarded. It's not necessarily evil because everybody has to make money and has to be profitable so that they can do things better. So I think when it comes to AI, I think there are new challenges. Patents or ICPs may not be necessary. May not be enough to protect the technologies or to incentivize the contributions. Just think of it. We have a new standard called JPEG AI. The JPEG AI is used to compress. JPEG it has been used for a decade, at least 2 decades, to compress pictures. And it is important and it's consensus-based because there are too many companies using it. Everybody wants to contribute some. Everybody has to use it, and so it is got to be a symmetric standard. Well, on the other hand, when we are filing patents, our researchers came to us and say, it's pretty exciting that he's got a standard essential patent, and then we look at it and what it protects. What it protects is the training method, how to train the model. And then we ask, where this pattern can be used by the ones training the data. Who does that? I did it. So the guy, invented the idea, has been the one training the data, and she actually put the data onto the website of a researcher based in Germany, by the way, on the standard bodies database website, so that everybody can download. And so who infringes the patent is us, is she, it's her. So it's not going to be sufficient to help the company really generate the revenue. So what can be helpful could be a patent covering inference algorithms, maybe something that would be done at a device level by software, by hardware. But but it might be necessary for there to be a mechanism to somehow reward the people really developing the training technologies, so that people would be incentivized to work on that. Otherwise, everybody will be just working on the inference models, but not the original training algorithms. So I think something else might need to be done there, more than standard central patterns.
Yeah, that's very interesting. I mean, it reminds me a bit of these open source specification groups in Etsy and other standards organizations where it's many different standards organizations at the same time are trying to incorporate open source processes into a standards development process, but they realize that there might be certain holes in the IPR policy and how to make sure that they can incorporate this under the umbrella of the IPR policy of the organization. And maybe if more and more AI technologies or AI processes are integrated in standards development, something similar might need to happen, and it could be an interesting conversation. Bo, you want to?
Yeah, just going to make a quick point. I think we might need to go back and reconsider. I think right now we decide people do a lot of R&D, and then they make contributions into 3GPP or other consortium organizations, and then they get rewarded for that based on what's covered in patents. It's worked. It's not completely perfect from covering all the work that's been done, but it covers it probably well enough for the system to work. If more and more things are not easily to cover through patents through that system, we might have to think what other contributions are given and how should they be managed in different ways, which is because patents have always been, a rough approximation of the work that people have done in their contribution, right? It's always that.
Yeah, and just to add to that, AI patents, there are different types of AI patents. One of them are the ones that are application-based, where you are using trained data, and those can be very valuable. I mean, we know like one of those auto-driving car-related AI patents, they're very valuable. On the training side, though, there still can be, included in the patent, but it needs to be, drafted in a sense that it's passively included and not necessarily. The things that are detectable are actually focused on the application of usage of that data, and then that AI patent is still valuable. And yeah, with respect to training, I think most of the companies believe that they're trade secret, and obviously the trade secret, they are valuable when they discuss the technology with other companies. There can be license around it. There can be different ways of incentivizing that type of trade secret.
Yeah, I agree with it with Siddhi that I don't expect, at least in the near term, the model itself being licensed, being open and then ready to be patented. I think it'll be mostly copyright, and then secret sauce companies will keep it to them. I think the opportunity for others who are not into model development itself is more of application and specific to the domains. For example, if you take wireless, there's a lot of things that are specific to wireless use, and a lot of times the companies might be using their own, not LLMs, but SLMs, domain-specific models. Those could be opportunities for patents. Wireless is one. If you look at health and medical domain, there's a lot of scope for that you develop specific models, SLMs, not LLMs, for specific applications. Then those could be patented as well, again, copyright or patented. So there is scope for that. And going back to the openness, it's not just now that there are questions on how open is open, right? I mean, I used to work on both Wi-Fi and the 3GPP side. Guess what? All the Wi-Fi crowd said 3GPP and cellular is not open. Because although anybody could get into 3GPP, but it is so much controlled that not many people, if you look at the contribution center, it's the same set of companies who are doing it. So the questions on what is open and how much open is open, I think it's more pronounced now with AI, but it's been around for some times, right? So,
open source, like the Apache license or MIT license people, they think everything's closed compared to
yeah, so.
Yeah, I mean, of course, openness has been a contentious word in standards circles forever. It's just that with every new technology, it gets a new flavor. So the issue of trade secrets was interesting also, because if it's an important form of IP in this context, of course, trade secrets can be licensed, but I'm a little bit wondering how that would fit with this ex-post licensing model that we know from SEPs. I mean, it's difficult to ex-post license a trade secret. Once the person has acquired the trade secret, it will be difficult to get some kind of return for that. So even incorporating trade secret licensing into standards development might be difficult, or might at least require some thinking how that would be done. But on that, I wanted to open it up to see whether people from the audience have questions for our panelists on any of the topics that we have discussed. So.
Try to block out of your mind that drinks might be waiting for you.
If nobody has questions, I have one more comment on in terms of patentability. So we talked about technical standards, and if you look at the responsible AI regulation related stuff, if companies come up with novel ideas on how to make sure the privacy, fairness, and other things can be implemented, I think that's another area of scope of where SEPs could play a role. Right? It's not so much secret sauce, but they come up with novel ideas on ensuring these things. So I don't know. That could be another area where SEPs could play a role.
When you listen to, again, Mark Zuckerberg talk, he'll say that, well, we release, again, Llama under open source, but we can argue whether that's true or not. But he also says that, well, if like Microsoft Azure is going to put it into their platform and then sell it, then of course we would like some money. So again, all these types of models are open until certain people use them in certain ways. So they aren't completely open. They're using their control of it to put in constraints depending on how people use it, right? And that's, again, the strategic openness again, because real openness is public domain. And then you can't tell people what to do with it, right? So.
Yeah, I mean, maybe given that we have some time, I mean, for me, the
second tallest guy in the room has a question.
Okay, let's go for that.
Yeah, maybe one question, because AI was also discussed in the past years a lot about generative AI in terms of if an AI files a patent, right? You can use AI to file patents. And I was wondering, if you think about standards development, I could also see with all these people coming in with ideas, could AI help in the development of a standard? Taking the ideas of contribution together and optimize the input to a certain way that it generates something. Any thoughts on that? I mean, both generative AI filing a patent or writing a patent, or generative AI writing a standard. What are the thoughts about that?
Tim is trying to put everyone out of work. Alan, what do you think about that?
I think Tim wants to solicit some ideas to build their future product. Well, I think it can be helpful. For example, if somebody, a standard researcher, he's got an idea, he can put in your system. Your system can help him to find all the relevant, technologies immediately. I don't know, your semantic search engine, and then it could be useful for the because there are just too many information. Some information are in form of standard contributions. Some information are in forms of filed patent, published patents. And so if somebody can put in their ideas and find all the relevant art, and it can be helpful. It can be even helpful internal to a company. Let's say Huawei has 500 wireless engineers work in the standard area, and different teams may have similar ideas. So a semantic search engine can help them to find relevant Rs and what other colleagues have been doing, even they are not published. So definitely it can be helpful, and it can also be helpful to help the patent agents. For example, when we have to put together ask the inventors to put together an invention disclosure, and your system can generate, for example, this disclosure, invention disclosure, by putting relevant information together, and then the patent agent, not necessarily the real expert, got to be an expert, but not the top expert. They're not inventors, right? They're just know the knowledge, know the field, but they may need additional information to help them to put together the application. Eventually, the claims has to be verified by the inventors, but in the process, certainly a lot of things AI can help.
Yeah, I even suggested that the European Commission, that the next version of the AI Act could be done by AI. That might be a conflict of interest.
I would ask the question, who owns the model which generated these contributions, right? Is it your company owned, or you license it for somebody? Under what conditions did you license that model from, right?
Just to add to that, there are so many firms and startups that are trying to come up with a generative AI tool to draft patent applications, and we evaluate those tools on a regular basis. So far, we've encountered that there not one tool yet available that can draft the patent application based on disclosure. There are ones where you can have drawings and claims, and they would draft a decent application. However, the attorneys are still spending more time fixing the errors from generative AI versus so the time spent is not reduced by usage of these tools yet. And then usage of generative AI for standards, I think, also requires that additional detail that could be hard to, at least AI is not at that stage that would understand all of the complexities and patents associated with the patent to be able to validate or verify all the SEPs or develop a standard.
Okay, we have one more question.
Yeah, so kind of to Tim's point, I'm aware of a couple projects where they're doing exactly that thing. But my question really relates to, we're talking about AI as a single AI, but the wireless networks, the networks are becoming converged and much more complex and concatenated in series and parallel. What are your thoughts on if every network has its own AI, they may be competing against each other? It seems like we need a standard so that the AI from a LEO or an optical or a DOCSIS network coordinates with a 5G or 6G AI. Any thoughts on that?
Yeah, well, this will be the issue where people are, where do you standardize and where do you compete, right? That's on that line. Where are we going to be equal and interoperable, and where are we going to add our own differentiation?
Sorry. Yeah, I can talk about what companies like ours have been doing, because I think indeed the networks is becoming more and more complicated. Fixed network, core network, and also the wireless, and more and more it's more and more important to our economy. So more money is spending into it, which leads to more complicated technology and more complex networks. So a challenge the carriers have been facing, the service providers, telecom service providers have been facing, is to diagnostic the network. When there is a problem, somebody cannot access the network, and can be very, very difficult to find out what is wrong. So the AI has been first, I think it's probably first used, considered important tool by our service team. So instead of Huawei's service team, there is a the developers used to be only developing products, but they are developing tools to help our customers to diagnostic their networks, to troubleshooting the problems of the networks. So not really, helping one network to beat another one, but I think artificial intelligence, it is important in this circumstance. It is I think some kind of openness would be helpful, but in the past it has just been the network management protocols, MIPS. Different protocols has different ways to interoperate with the management systems, but when there is a center point of data, still there are people, analyzing the data, looking at each of the error messages, but thousands and millions of these error messages. How to find out what should be fixed, and where is the root of these errors? AI is used right now by carriers and companies like ours to do it.
Yeah, just to add on to that, there's a lot of AI right now being used in wireless networks. I was talking to CTO of Thales. He said basically they have digitized all their manuals and everything for their techs. So if there is a problem in the network, instead of tech going through manuals to do the troubleshoot, basically they have a chatbot kind of interface. So they type in the trouble they're seeing. So the back end, it's all digitized. So their AI model basically scours all of the resources and comes out with just like ChatGPT comes out with the possible reason for that troubleshoot. So that they said has improved their productivity by at least 20% at a very early stage. So there's a lot of, and in terms of analytics, wireless networks are built for peak capacity, right? And that capacity is used for probably 1 hour in the full 24-hour day, which means there is a lot of potential for saving energy. So you basically keep the channels and the spectrum, the bandwidth, and so on only as much as needed, not more, not less. So a lot of that is happening. So to directly answer your question, some of that is starting to happen in wireless, as I said in release 18 and 19. So basically models in the networks, it's the models developed by infrastructure providers, and then the devices have their own models developed by device manufacturers or SoC modem manufacturers and so on, like Qualcomm, for example, right? So they cannot expose all of the model to each other because that's their secret sauce where they drive their differentiation. But you got to make sure that they work in conjunction, not against each other. For example, one of the use cases they're looking at is, in terms of channel estimation. So very frequently, phone sends the condition of the channel to the base station so that it can adjust its configuration in terms of modulation, coding, and other things, so that the performance of the link is at its peak. But it takes a lot of time for the device to take the measurements and sends it up, and for the device to process that, and then it adjusts its configuration based on that information. By the time it applies that information, the information it's using is already stale, right? So there's a lot of errors because of that, and also sending all of this data every time, these reports on the uplink, eats a lot of bandwidths and increases the overhead. So if you can predict using AI algorithms on what the channel condition is going to be, then you can save all of this, right? But again, you've got to make sure these two models are working with each other. And that's not an easy challenge to fix. So that's they're figuring out, come up with a framework wherein a minimum amount of information is exchanged between the models in terms of what goes in, input data, and so on, and the framework, so that the outcome is additive, not subtractive between the two. The same model can be applied across networks. That's what your question, right? Across fixed networks, mobile networks, and other things as well. But nothing of that is happening right now, but there is potential.
When Prakash was speaking, it gave me an idea, Tim, that maybe, here you said who's coming in person, right? And who's on virtual, but maybe in a few years it'll be which one of you is going to be human versus chatbot, right?
All right.
We laugh now, but wait, in a couple of years, right?
I think we're nearing the end of this session and the end of the program, actually. And I maybe just like is in one sentence to wrap up a little bit. So I think that AI technology is advancing very fast. So as many dynamic technologies, standardization needs become clearer over time. So probably we'll see more of standardization of AI technology going forward. Also, AI is everywhere already, including in standardization, including in the standards. But as with many other aspects of social life, we haven't yet figured out how society needs to change, how our processes need to change, how our policies need to change. So like it's many of the things that we recognize from other aspects of business and social life are also true for standardization. So maybe we'll do another session on AI and open standards 1 year or 2 years from now, and we'll have many more answers. But this was already fun, and thank you very much for the insights and the experience from the panelists. Kirti, Tim, I mean, it was fun doing this again with you this year, and I'm very much looking forward to hopefully doing it again next year. And with this, I think we can close our panel, and thank you very much to the panelists.